It has started.
Okay, great. Thank you. Okay, so let's recap what we have done. In the last class, we have started with our introduction to functions. We have, in fact, the first class in the week was about, it was still about arrays, multidimensional arrays and so on. And we looked at a few questions on multidimensional arrays, not too much, but some of them, and you also did one or two questions in the quiz as well. We also introduced functions and we talked about local and global variables and saw that all variables are passed by value in C, and however arrays being addresses, they are the way they are passed, the address itself is passed, and therefore they behave differently from the basic data types like integers, floats, or characters. So in this week, we are going to work more on functions, and especially we are going to talk about recursive functions, which are very interesting, and writing recursive functions makes things exciting as well as quite enjoyable. So I hope you will enjoy this week where we are going to talk about recursion. Okay, so just a very quick recap. As we all know, in C there is at least one function, and that function is the main function. It can be composed of several functions, and as you write bigger and bigger software, you are always going to modularize code. And one of the ways to modularize is write it in functions. In fact, it is also recommended, and we will have one of the examples later, either this week or sometime next week, where we will talk about how to split functions into different files, how to compile these files together. And we have already shown this to a very, very small extent, where we said how to do GCC minus C. It does not create an executable. And then how to put together all these object files and create them and combine them and create an executable out of them. So this is about how to split your functions. But once you have split things into functions, you want to communicate between functions. So the communication happens via these arguments that are passed to the function and the return types, as well as these global variables that we have seen, you have already seen, as well as exercise that in the exam, one of the small questions that was there on global variables. And I hope the exam question also told you that it can have side effects and you have to use it carefully. Okay, so so as we have seen that the basic data types that, in fact, everything that is passed in C is by value, and therefore when you pass integers, characters, or floats to a function, then the changes made to these parameters are not reflected to the caller, and therefore in fact our swap function does not work. This was again very subtly tested in one of the questions where you were asked to do the largest palindrome, which is smaller than a given number n, where you were given this reverse function which was internally modifying this n, but you should remember that this is a call by value, therefore the variable n, the changes made to that variable n are local to that function and do not change when you come back to main, which was calling it. So this was a very subtle way to test it. I don't know whether you realized it. Some people also commented that that question was incorrect. So I don't know if that was the confusion that they had. At least I don't believe that the question was incorrect. But that is one of the things that we also wanted to highlight using that question. So this is something that we have seen. And if we want to write a correct function, which for the swap of two integers, we require pointers, which we are going to deal with in the next week, possibly, or maybe towards the end of this week. On the other hand, when we deal with arrays, we remember that the name of the array itself is the address of the first array element, and therefore whenever you pass this, the address again gets copied, And whenever changes are made to the array elements, they are reflected to the caller. In particular, we have been calling functions from main, and you have seen this in several examples in the class, in the lab, as well as in the exam, and you are now quite comfortable with it. And many string modification functions rely on this, right? So this is something that we have seen. Any questions, comments here? Okay. Okay, so coming back to global versus local variables, I want to recap that the lifetime of the global variable, that is when is it available in the program? It's the complete program. The global variable is available from the time it is defined to the end of the program. So once you have defined it, it is always available to every function that is defined after it, and the scope is everywhere after its definition. So you can access it everywhere in the program, including the functions, including all the functions and so on, including main, etc. So however, the name of the global variable can be masked by a local variable of the same name. For example, in this snippet, we have this int g. So I have not written include stdio.h, but int g, which is a global, which is assigned 10. And then there is a function fun, which takes some parameter x. It returns also x. And there is another integer variable, which is also named as g. So when you print this printf, when you execute this printf statement inside this fun, then the variable that you are accessing is the local variable g, not the global variable, because that is the nearest one which is in its scope. So that is the one which is going to be accessed in this function. So the nearest one which is alive is going to be accessed, and that is the one which is going to be printed here, which is g here. Which is g, which has a value equal to 20. So are there questions or comments in this part?
Ma'am?
Yes.
Not in this one, ma'am, but related to the global variable part. Like in the exam, there was a question, ma'am, where a global variable g was declared, and the same variable g was passed as an argument to a function, and in that function, like we took it in an input. Well, like in the function we had x as the input, ma'am, for g. Like we write a function in x, no, ma'am. Like argument.
This function x, right? Input,
Yes,
int
exactly,
x,
yeah.
right?
Yes, ma'am.
Yes, it is also x here. Yeah.
So yes, ma'am. So basically, the x takes the value of g, and inside the function, this x was also given a value. Like x was, I think, for me it was given 10, I guess, and
Okay.
g, the global variable, was given, like g was written as g is equal to g minus 1, ma'am. Like
Yes.
g is equal to, and written x plus g. So while in the return statement, again, will x be, while it is returning the value, will the change which we made to x, will it be reflected in the program, ma'am? Because like in the swap function, the swap was
So
not done,
just
ma'am.
hold on, Kanikeshwar. So if I recall the exam question correctly, the only thing that was there was main was, I mean, in main, it was similar to this, except that x was assigned a value here, right? X was assigned some value here, which was the formal parameter to this function. X is equal to something was given, right?
Yes, ma'am.
In the body of the function, x is equal to something. So please note that whenever you are passing from main main some variable, the copy of that variable is something that is going to be, so this it is passing that variable as a parameter to this function, and that is that is for this variable x, right? So a copy of that is going to be made into this variable x. Is that clear?
Yes, ma'am.
And therefore that x is going to be changed. So I think it was x is equal to something, x is equal to some value, right? Yeah. So Karthik is, thank you Karthik, you have, okay. So x is equal to 10. One of the variants was x is equal to 10. So that x is the local x that is getting modified. whereas G is equal to G plus 2 is the global G that is getting modified. So Karthik's variant is G is equal to G plus 2. That doesn't matter. Is that clear?
Yes, so G being a global variable, so it can be, we can change the, like, the value change will be reflected, no ma'am?
Yeah, but please note that in the exam question, there was no G redefined in the function, right? So there was no question of which G is being accessed. There was only one global G which was being accessed, and that G is getting modified.
Okay, ma'am. But in terms of return of x plus G, won't x value, because like we are giving the function the value of G, ma'am.
Yes.
But in which we are copying it to x.
Okay.
And we are returning
So,
x plus G.
yeah.
So
Yeah, okay. So, Kandikeshwar, I think, yeah, so this is a good question. And I mean, yeah, actually, I should say it is a good question that it was framed for the exam. But it is the question that you're asking is also good. What I will suggest to you is first work out it on a piece of paper. Maybe you got it wrong. And then I will send to you, I mean, the link that we have seen, right, which allows you to visualize code, right? Please use that link. I will send it to all of you. Please use that link to visualize that code. That piece of code is very small. You can initialize that G on your own, although it was a fill up, and then see the execution of that program, and you will understand that in fact the local variable is copied. Here the local variable is the one which is going to be changed. Can you hear me?
Yes, ma'am. Like you froze for like around 30 seconds.
Okay, sure. Okay, sorry about that. So I will just ask anybody who has difficulty with that. I'll share with you the link which is for visualizing the code, and please visualize that code. It will be immensely instructive for you to check out what is happening. Is that okay, Kandikeshwar? And then if you still have doubts, I'll be happy to answer in the next class or maybe in an email.
okay, ma'am.
Sure. Okay. So I hope this slide is clear to everybody, and the redefinition of G is also clear, and the G that is accessed in the printf is the local G, not the global G, because that is masked by the local variable of the same name. And this continues inside blocks and so on. Okay, so the local variable, for a local variable, the its lifetime and scope is the block or the function where it is defined. For example, so this example is specifically created for you to understand a few things. So although it uses char star, do not worry about that if you are not familiar with pointers. It is a way to return a pointer to return the address of an array at the address of a character array. At the moment, don't worry about this if you get I mean, if you have not seen this. But let's say that you have you want to write a function which is my copy, which takes as an input a character array and returns the copy of the character array. One of the things that one can think of is, okay, let me define a character array inside this function, which is str. Make a copy of that. This code is something that you know how to do. For I is equal to 1 to as long as you don't see the /0, you keep copying, and then return this address of this, return the address of this. This is something which is incorrect, because this is a variable which is local to this function. Once the function ends, the stack, I mean that everything on that stack is gone, and therefore that variable which was assigned memory on that stack, which is for this 100 character array of size 100, that is gone, and you are returning the address on that memory location, which can be used by some other function which is invoked. So this is something which is completely incorrect. This is a local variable whose address you are passing to something else. So this is not something which is allowed. In fact, you know that if you look at string.h functions, which allow you to do string copy. They will have two parameters, one the source, the other the destination. And here you are making use of the fact that although the call to everything is passed by value, whenever you are passing these arrays, whenever you pass the second array, which is the destination array, the modifications to the destination array are also reflected in the caller. So this is something that is important and that is used very heavily when you write string functions. So this is a wrong way to do this, that is returning the address of a character array which has been defined inside the inside this function. So any questions here? Any questions, comments? Okay. Okay, so we are going to define one more, this is a keyword which can be assigned to some variables as well as functions. We'll come to it later. So Ashwin, did you have a question?
Ma'am, yes, ma'am. So any pointer defined inside a function should not be returned. That's what you're saying, right?
No, I'm not saying that. I'm not saying that. I'm not saying that you should not return this. You should not return the address of anything that is defined inside the function, because you will have to return the address of some things which are defined inside the function. However, when we do that, you need to get memory via malloc, which is on a different data storage, which is called the heap, and not on the stack. Currently, whatever we are doing without malloc, the way we are defining this, defining these variables, all of these are allocated space on the stack. I have shown you the execution visualization of the execution, where you see that the main is there. There is this function stack which is running, and the first function that is called is the main. Below that, the next function will be called whichever is the next function. Let's say that main calls my copy, then on the top of the function stack, there will on top of that execution stack, there will be the stack frame for the my copy, in which you will allocate this array, which is this str, which will be erased when this function returns. However, if you allocate memory using malloc, which we are going to do soon when we define pointers, then you are going to allocate memory at a different place, which is called the heap, and that heap is active. Therefore, addresses into the heap are something that you can return via the function. So is it clear? I'm not saying that you should not return addresses from functions. You can, but the memory that is allocated should be on the heap. Then it remains valid even after that function has stopped executing. Function has completed the execution.
Yes.
Is it fine?
Yes, ma'am.
Yeah. Good question. Thank you. Okay. So so the next thing that I want to talk about is this keyword that is called as static, which can be prefixed to variables. In fact, it can be done for other things like functions as well. I'll come to it in a minute. But the most common use of this is saying that a variable defined is not. So this is what we are saying, that this is the type of the variable. This is the name of the variable. The type of the variable already talks about the size or the number of bytes assigned to it. You know how to find that out by size of. There is also a value assigned to the variable, which if it is not initialized, it is garbage. If you initialize it, it is the value. This is a static variable, which says that all the variables which we have not said anything about are called as automatic variables. You can also say auto int x, which is also fine. However, since everything by default is automatic, we don't say this. And such variables, when you say that some variable is static, this variable is created once at the beginning of the program, and it is initialized only once at the beginning of the program. So although it may be defined inside a function, it is initialized only once, and the lifetime of the static variable is throughout the program. That is, it is available or it is there throughout the program, and however the access control is the same as a local variable. That is, let's say it has been defined inside a function, then you cannot access it outside the function, or if it has been defined inside a block, you cannot access it outside the block. However, it is there, it is available, or its lifetime is throughout the program. So this is, so in some sense it is like a global variable because its lifetime is throughout the program, but in some sense it is like a local variable because its scope, that is it, the places where you can access it is similar to the local variable, that is it can be accessed inside the function or the block that defines it. So this is what is the what the static I mean having a prefix for a variable called static does. Let's see this as an example. So let's say that you have this yeah, so I'll come to what is static used for. Just let's understand the behavior and what static is used for. I'll tell you. So let's look at this program. This int main and do something is, I mean, it's a harmless function. Nothing is happening there. It's very regular. Just that inside this for loop, I is equal to 1 to I less than 10. So 9 times we are calling this do something. In this do something, I have two different variables, x and y, and both the variables are integer variables, and their type and their storage class, in fact it's called the storage class, is static. And this static variable means that this will be created and initialized only once during the program. So therefore this x will be initialized equal to 5 at the start of the program. Similarly, y will be initialized and created at the start of the program. But note that I have artificially created a block here, which is this block outside which y is not accessible. So although y is, the lifetime of y is throughout the program, y is not accessible outside this block, which is, let's say here y is not accessible. Similarly, x and y are not accessible here in main. So you cannot print x and y here or access them. You can only print x and y here and print x here or use x here outside as well. As soon as it is defined, it can be used, but it cannot be used outside this function do something. So the scope of this variable remains like a local variable, which is restricted to the block or the function, but its lifetime is the whole program. So let's see what happens when this program executes. So think of it that yeah, so think of it that this program that this global variable, sorry, not global variable, this variable, static variable has been created at the start of the program. This memory location is given to it just like a global variable. However, unlike a global variable which could have been accessed anywhere in the program, you cannot access it. So this 5 and 6 have been initialized to x and y respectively. Now when you first time go to do something, it is going to do x plus plus. So x is going to be incremented by 1. So it will print 6 for x and 7 for y. Then this is something which all of us will agree. The next time when we go into the function, it is not going to initialize this x equal to 5 again. So in fact, x was 6 because the x plus plus has happened. Therefore now it will again do x plus plus. Therefore x will become 7 and y will become 8. And then 7 and 8 will be printed in the next iteration. Then 8 and 7 and 8, 8 and 9, and so on. So I hope you see how the function is behaving differently. If you had not given this static, every time you would have just had x is equal to 5, y is equal to 6. And in fact, then the program would have printed the same set of values, which is 6 and 7 every time in the loop. However, it prints different set of values for every iteration of the loop because of the variable being defined as static. Okay, so is the execution of the program clear and why it is doing so? Okay, so one of the questions is that what is the meaning of the lifetime of a variable? So the lifetime is when is it alive, right? So when is this variable alive? So once this int, okay, so let's ask for this int I. So this int I is created as soon as the program is program starts executing, that is once main is called, and it is alive till the program terminates, right? Because that is, it is there in the whole of the scope. So it will be alive when it is, even do something is called. However, do something cannot access it because it is not in the scope of do something. So it is alive, it is there, but it is not in the scope of do something. So do something cannot access I. Same way, the static variable is alive. It is created as soon as the program is created, even when do something is not active. So let's say that you did do something, then do something else is there. So the frame, in the stack, the frame for do something else is now active. So do something is not active. Still, X and Y are both alive. They are there. Memory is there for them. They are not, the memory is not destroyed. Unlike if there were some other variable Z, which was an automatic variable that is non-static, then it would have been alive only for the time do something was alive. But when you say do something else, then it would not be alive. So I hope it answers your question. What is the meaning of the lifetime? When is the variable alive? The global variables are alive throughout the life of the program once you have declared them. Okay, so so when I run the program, the static initialization will run only once. Yes, static initialization will run only once. So the static variables are initialized only once, and if you leave them uninitialized, then they are initialized to 0. Again, a bad idea to assume that initialization will be taken care by the program. Any other question? Yes.
If we define a function, if the function is not even called, will the variable defined in that function be alive?
Okay, so the question that I think Satyajit is asking, if I heard it correctly, if a function is defined, let's say do something is defined, and let's say there is a static variable X, let's say static variable is defined in this function, and let's say there is an automatic variable Z which is defined here, right? So then if if this function is never called, then the automatic variable will never be alive. On the other hand, the static variable will be alive, but you can access it only inside the function. So having a variable defined inside, even a static variable defined inside a function, and it being alive doesn't make sense because you cannot access it outside the function unless you call it.
Understood.
Does it answer your question?
Yes, ma'am.
Okay. Okay. So one of the other questions was that what is the use of a static variable? So one of the uses of the static variables is to nicely count. Let's say one of the example cases is to count the number of times this function is called. Let us say this do something is a very, very important function. Just like think of it as a swap function. Not we still don't know how to write a swap function for two integers, but let's say we write some important function, or let's say we are interested in counting the number of times some comparison happens, then that is something that we are very much interested, but that is not happening only through a particular call through main or something. There are multiple functions that are calling to compare two values, and this comparison is very expensive for you. Let us say you want to compare that, you want to count the number of times this function is called. Then let's say this do something is such a function, then you can define a static variable, let's say static int count, and initialize it to 0, and then keep incrementing that count, right? Of course, you also need to know how to print it. So every time you can print it, that you are trying to print it, and it will keep printing the number of times it has been called. That is one way. You have to think of how should you print it in the end, the number of times it has been called, to record the number of times this function has been called. So this is one of the use cases of a static variable. It can allow you to count the number of times this function has been called. There are other use cases of a static storage class which can be used with other things as well. Okay, so yeah, just so this is something that you may or may not use, but you should be aware of that there is this thing that you can prefix something with what is called as static, and this is the meaning of when you say that there is a variable which has been defined as static. Okay, so can we declare a static array and return it from a function? Remember that its scope is not outside the function. So you cannot, just because you said that it is static, it doesn't mean that it is accessible outside, right? As I said, even this integer variable x, its lifetime is throughout the program, but you cannot access it outside the outside this function. So you cannot assume that you will define a static array and return it from the function. That is not allowed. So that is one of the questions. Okay, so I just want to mention, yes.
Ma'am, so does that mean we can't return x and y here?
No. I am not saying you cannot return x and y here. But I think what the question was is that okay. So the question is, can you okay, so when you return it, it is again a return value. It is not an okay. So you are saying that can you define and can you return int star? Is that the question? I think Gitartha has asked, right?
Yes, ma'am, that's what I asked.
Okay.
Earlier you told that if you return the array, then it would be, the space would be freed. We won't be able to access it. So I was asking that.
Correct. Yes. Yeah. So when it was an automatic variable, right? When we had defined it in the previous slide, right? Okay. So your question is, can you okay, so see, whenever, okay, so this has also to do with where the variable is stored, right? So the variable is not stored on the, so I recall that there is a call stack, I mean execution stack which is going on. So the main function has its the stack of that, and then on top of that there is do something. However, this int x and int y are not defined inside that that place on the stack. It is defined on some global place where the global variables would have been stored. So can you return the address of a static array which is defined here? I am not sure. I'll have to try this out and let you know. I'm not sure. I take back my words, Gitartha. I'm not sure whether you can return it and whether it is a valid thing to do. So I'll look it up. I'll try it out and let you know.
Sure, ma'am.
Yeah. Thank you. Yeah, so please remind me if I forget to answer that. Okay. Yeah, was there any other question on this? Okay, so I just want to mention that you can also have a static prefix for a global variable that is defined, and it has a slightly different meaning. That is, the use of this variable is restricted to this file. However, we have not yet talked about splitting programs into different files. So therefore, we will just now not talk about that. But I want you to remember that static can be written for global variables as well as functions, and it means that these things, that is either the variables that are defined inside defined global variables which are defined as static, their use is or their access is restricted only to this file. Similarly, if I say static void do something, then the use of this variable is restricted to this file only. And what does it mean to this file only? Currently, we don't even know how to use this function in another file. Therefore, this doesn't make too much sense. So when we come to splitting functions into different files, we will also talk about another prefix that we can use, which is called as extern, which says that there is a variable somewhere or there is a function somewhere. I'm not defining it. I'm telling you that the prototype is this. It will be defined by somebody else in some other file, or there is a variable of this type but I am not allocating memory for it, in which case you can talk about externs. And that is where you can talk about sharing things via different or splitting things into different files and then combining them when you are combining the whole .o files into an executable. So since we have not talked about that, we will not talk about having static for globals or functions at the moment, but it is in some way kind of having this access control which C++ provides by public, private, and so on, in a very limited sense in this setting, right? So it allows you to restrict some things to the file. C allows you to restrict that. So just to recap, we have talked about local variables, its scope and lifetime, global variables, its scope and lifetime, and static variables and its scope and lifetime. And we have not seen a very good example of static. We will try to see if we can create an example where we can make you use static in possibly in the assignment or something. But at the moment, this is what I wanted to tell you about these three different things that you should be aware of. And we'll come to extern when we talk about splitting programs into different files, and there is where we'll require extern. So I think at this moment, I would like to take this logical break. Maybe we can, yeah. So I'm going to pause. Okay, so getting back to what we want to do importantly in this week is about recursion. So if you have not seen this picture earlier, I encourage you to stare at this. This is one of the very classic pictures of what is the essence of recursion. This is a sketch by MC Escher, and this is called as the drawing hands picture. There are various pictures which depict recursion. This is my favorite, which depicts recursion, and this is what it says. I mean, the function, or you define something in terms of itself, which seems something which is I mean, although we have now seen recursive functions already, you know, factorial and so on, it doesn't seem that surprising. However, initially to think about something defined in terms of itself seems to be something which is surprising. So this is one of the pictures which depicts recursion, and I like it very much. So if you have not seen it, please look for MC Escher's pictures and you will see very interesting pictures of him. They are available on the internet easily. Okay, so yeah, so the question that one comes to somebody's mind when we talk about functions is that we know that functions call each other to communicate. So A calls B, B calls C, C calls A again, and so on. This can happen. So now can it happen that A calls itself? And this is what is recursion, and recursive functions allow you to do that. And C supports recursive functions, which is allowing functions to call itself. And a recursive function or a recursive definition knows only how to solve the simplest case. And this is typically called as also the base case. And if the function is invoked using something which is complicated than the base case, then it breaks down the task into something that the function knows how to do and a part that it does not know how to do. And the part that it does not know how to do, it is going to repeat and call the same function, and this is called the recursive step. So this is something which is interesting and tries to capture how a recursive formulation or a recursive function is typically behaves. And a lot of you have already seen recursive functions, but what we are going to do in the remaining part of the class is to do simply recursive thinking. I mean, we will also write some parts of it in code, but the fun part of it is to think about things recursively, about things that we know, which will be easy, about things that we do not know, and thinking about them recursively is something that is a lot of fun. Okay. So, yes.
What does it mean by simplest case and complex case?
Yes, so that we'll come to it. So what is simplest and complex case and so on depends on the thing that you want to do using recursion. So not everything can be formulated as a recursive problem. There are some things which are naturally recursive, and we will try to show you use cases of that. And as we go along, you will see when to think about a problem recursive. Right, so the simplest and the complex case, etc., are very much dependent on what we want to solve. Okay, so the first thing that most of you have already seen is this is the factorial function, which is f of n is equal to 1 if n is equal. So let's assume that n is a positive integer. If n is equal to 1, then f of n is equal to 1. Else f of n is equal to n into f of n minus 1. This is what we all know is the factorial function. So the simplest case here to answer his question is if n is if the input is provided as 1, then this is the simplest case. That is all we know how to do. If the input is anything which is complex, that is more than 1, that is what is the complex case, then we know that we don't know how to do that completely, but we know that it is n into f of n minus 1, that is factorial of n minus 1. So f is, or factorial or f is defined in terms of itself, that is it is n into factorial of n minus 1. So this is the recursive definition of factorial, which we all know, and this translated as a function is given to you. So you have defined a function which returns an integer, and it takes as an input an integer, and if n is equal to 1, in fact I have written it the other way, that is 1 is equal to n, which is equivalent, then you simply return 1, else you return n into factorial of n minus 1. So this is the most simplest thing. The whole thing is very simple. Don't worry about simplest and the complex thing. But if you want to break it down, then this is the simple part of it, which is the base case. And this is the recursive step, which says if you get something which is not 1, then you have to go to n into f of n minus 1. So any questions on this part? Yes.
So here in the last statement, it will call the function again. Like it will be going into the function again and again.
Yes. Yes. So I would like you to think about how this function works for n is equal to, let's take a small value, n is equal to, let's say 4. So if you call fact of 4 from main, then fact of 4 is called 4 is not equal to 1, therefore it is going to say n into fact of 3, and then on the call stack you are going to, on the execution stack you are going to see main fact, which is being called with the parameter which is 4, then the call which is with parameter 3, then the call which is with parameter 2, then the call which is with parameter 1, which is going to return the first, which is going to be the first one to return, because that is on the top of the stack. In the visualization that we see, the stack keeps going down, but doesn't matter. The top of the stack is going to be the one which contains the final one, which is the call for fact of n is equal to 1, and then it will return 1, which will go to the next one which had called it, which was n is equal to 2. So it will be 2 into 1, which will return 2, and so on. And this is how this factorial function is going to operate. So the last one to be called is fact of 1, which will return to fact of 2, which will return to fact of 3, which will return to fact of 4, which will return eventually to main. So any questions here? Okay, good. So we move to the next function, which is which we want to talk about recursively, which is multiplication as repeated additions, right? So I want all of you to formulate this as a recursive thing. So there is, assume that you want to write it recursively. So you want to write multiplication as repeated additions. How will you write it? What is the base case? So assume that you want to write some function just like we did. You can call it mult of xy, how will you write mult of xy? What is the base case? And there can be different base cases for each of you, the way you think about it. And then how do you write the recursive step? Just write the mathematical formulation. Don't get into writing code. So let's just all of us take this function mult of xy and try to write that. Just think of them as two positive integers. Please type out your answers in the chat message. Just type out one line which tells the formulation. If something happens, then it should return out very easily. Else it should return out something which should call mult possibly. Okay, x plus x plus x plus x plus x. No, that is an iterative way of thinking about it. So you are thinking about for I is equal to 1 to x, do y x, or for I is equal to 1 to y x, right? That is an iterative way of thinking about it. Yeah, it is correct, but it's an iterative way of thinking about it.
Ma'am?
Yes.
Just one thing.
I would like you to, unless you are asking a doubt, I would like you to write. Yeah, okay, go ahead.
Can you just tell what multiplication using repeated addition means from this case? Like,
sorry?
No, like what do you mean by multiplication using repeated addition, ma'am?
So multiplication is indeed repeated addition, right? So x plus y, what is x plus y? No, sorry, not x plus y. What is x into y?
X into y means
what is x
we are
into
adding
y?
x, y
It is it is for y times you are saying x plus x plus x plus x and so on, right?
Okay, ma'am. Yeah, I get it.
Okay, so I see answers that people are giving now. Please write out your answer in the chat. Yeah, very good. Yeah, I still have only a few handful answers. Yeah, please do not write code. That is not the purpose. When you are asked to write a recursive mathematical formulation, write it. So that is why I have made it into two parts in the previous slide where I have shown the mathematical formulation. This is the code part of it. So I don't want you to write code immediately. Okay, so writing it as a loop, which is just saying do something, is not going to give us the recursive formulation. Okay, so in the interest of time, I'm going to show the mathematical formulation. So if x is equal to 1, then there is nothing to do because we just want to return y, because then, so we know that these are positive integers. So if x is equal to, if x is not greater than 1, it means that x must be equal to 1. So we are going to return y. This is fine. If x is greater than 1, then we know that we will have to add y to whatever we get for f of x minus y and 1. Whatever we get as the multiplication of x minus y and 1, we want to add y to it. And this is one of the ways you can do the recursive formulation. This is not the only way. You can, of course, you could have done the base case as y is equal to 1. That could have been also a symmetric way of defining it. So there is nothing special about this way. This is one way of defining defining this recursively. Any questions or comments here? So this is what I mean by the mathematical formulation or a conceptual formulation of this multiplication function. Okay, so this is the translation of this program. Please stare at it and tell me whether it is fine. Again, please write out your messages in the chat so that everybody gets to think about it.
Ma'am, if x equal to 1, then shouldn't it be return y?
Okay, so Yananda Gopal, you have spoiled this thing for everybody, but it's okay. I think it's an obvious mistake. So that's okay. So there is a mistake here. If x is equal to 1, then you cannot have return 1. In fact, it should be return y, and that is what is the change that is required to make this program correct. Otherwise, everything was fine. But if x is equal to 1, you don't want to return 1, you want to return y, which is y into 1 is what you had asked for. Otherwise, you have to say it is y plus mult of x minus 1y. So this is the translation of this recursive formulation. You can always ask, can I say y is equal to 1? Yes, you can ask for y is equal to 1. That can also be one of the base cases. So a recursive definition or a recursive function is not complete, or it is incomplete or not specified unless you specify the base case. And many times what happens is, in the hurry to write the recursive function, or just to, because that is the most interesting part of it, we forget to write down the base case, which can either, of course, I mean, if the base case is something like return 1 or something, it may be understood. Again, when you are asked to write it in a exam or a lab, you must of course write it, otherwise your programs will behave incorrectly. But if you have recursive formulations in which you can have recursive formulations in which the recursive part remains the same, the recursive step remains the same, but by changing the base case, you are going to change the function completely, or the output of that, of course, you are going to change it completely. Therefore, you have to be very careful about what you are writing as your base case, and you are formulating your base case also correctly. Okay, so having said this, let's move on to another example where what we want to do is find out the length of the string recursively, right? So before we write code for this, let's try to understand how will you formulate. Yes, there is a question.
Will we get an error if we don't define a base case?
Okay, what do you think?
Because like then it won't know what to do, right? If you don't define a base case, it won't stop. It'll keep going.
Will it be a compile time error? What do others think? The question is, suppose I do not write the base case, I write int mult xy, return y plus mult of x minus 1y, and this statement, what will happen?
I think it says out of memory, or
I'm asking, is it a compile time error?
no, ma'am. I think it will be runtime error.
Okay, so it won't be a compile time error. The compiler, unfortunately, is not intelligent enough to know that you haven't written a base case. So it is an incorrect program. It will run out of memory because it doesn't know where to stop. It is just writing. It is just like you don't have an exit condition for an infinite loop, or a loop that for which you are suppose you have not incremented your variable, right? Then the compiler doesn't know that. Is that clear? The person who asked the question.
Yes, ma'am.
Yeah, so not writing a base case is not a compile time error, unfortunately. Yeah, good question though. So therefore the compiler is not going to help you there. Okay, so let us think of how will we write the length of the string recursively. And at the moment we are going to talk about the length of the string in terms of C strings. That is, we know that it is a character array which is terminated by a /0. So in recursive functions, you will also have to be careful about what are the parameters that you are going to pass to the string. Not pass to the string, pass to the function. So in the previous functions, they were simple integer functions. So in the first function, you passed n. In the second function, you passed the two values x and y, which are again integers. What will you pass for this, which is in which you are interested in recursively finding the length of the string? And remember, you cannot pass the length itself because you don't know the length. There is no point in saying that I will use strlen to find the length of the string and pass that. That is not useful, right? Otherwise, you have already computed the length of the string. Okay, so before we get into writing the recursive formulation, what should be the parameter to this function? So let's say I'm going to call that function len or recursive reclen, recursive length. What should be the parameter to this function? Or what should be the parameters to this function if you want to pass more? Start index, end index into the string. What should I pass? Hello, are you there with me, or is it that okay, Kaushal, are you able to hear me?
Yes, ma'am.
We type in the chat, ma'am.
You're writing in the chat, is it? Okay. Oh, I'm not able to see it possibly. Oh, okay. Sorry. I missed it. Okay. Okay. I'm very sorry. Okay. Yeah. Okay. Okay. So some of you have answered it and some of you have answered it correctly. Some of you are saying that there is a character array and some index I. So I do not know what is index I. Why should you give index I and what does it represent? I'm not sure. So I'm going to just show you the base case, that is if str whatever has, let's say we are sending a character array to this function which is recursive length or whatever. If that character array's 0th element is equal to 0 or it is equal to /0, then return 0, because then there is nothing in the string and therefore we can return 0. Else what we are going to do is add 1 to the length of the string starting at str plus 1. And why is it okay to say str plus 1? Because we are saying that string is a character array of a particular type. I mean, it's a character array, and str is the address of the string starting at that position. At the beginning that you must have given, at the 0th place you would have called it. When we say str plus 1, then it will go to the first position and it will start looking at the string starting at the first position. So it crucially assumes that you have a /0 at the end of it, and that is what it is assuming. So if you see a /0 at the beginning, then you have nothing to do, you just return 0. Else you add 1 plus the length of the string starting at str plus 1. So I am going to leave you with this only, and I would like all of you to think about how to complete this function, which is which is going to write a recursive length of the string function. All of you should try it out on your own. There is no pressure of marks and so on. So try it out. Do not give up. Do not look up anywhere. Try it out on your own, and then we'll come back and complete this and many more problems that we want to think about recursively. So I'll stop the class here.